Hello again, and welcome to Astronomy Toronto. My name is Randy Attwood, and I'm your host, and also currently president of the Toronto Centre of the Royal Astronomical Society of Canada. Astronomy Toronto is seen on Rogers Cable 10 the first Thursday of every month at 8 o'clock in the evening. Well, Astronomy Toronto is Toronto's monthly astronomical news magazine, and tonight we have a very interesting show to put on for you. First, we're going to be talking a bit about the moon and what you can see when you look at it just with your naked eye, using binoculars and a small telescope. Later on in the show, I'll have as my guest Jillian Buriak, who's one of the younger members of the Toronto Centre of the Royal Astronomical Society of Canada, who does a lot of observing with her little telescope, but also she does something different. Instead of photographing the stars and the moon and the planets, she draws them, which is very interesting, and we'll be looking at some of her work later on. Well, first, with Astronomy Toronto, we'd like to try something a little different, and that is talk a bit about some astronomical happenings in the news lately. The big story in the sky this year, of course, is the return of Halley's Comet. Now, you may have thought of Halley's Comet, you thought it might be pronounced Halley's Comet. Well, a lot of people do that, but I think everyone's beginning to learn that it should be pronounced Halley's Comet, named after the astronomer who actually realized that a whole bunch of comets seen every 76 years was actually one comet returning in an orbit that returns every 76 years. So they named the comet after Comet Halley. Well, Comet Halley will be visible from Toronto later on in the year, probably by the end of November or early December. The latest news is that the best place to see Halley's Comet will not be from the northern hemisphere, but from below the equator in the southern hemisphere, probably in March or April of 1986. Again, it'll be visible in the evening sky in December and January, and then it'll go around the sun and be visible from Toronto in the morning sky in March, and April and May will probably be times to see the comet. One of our guests on Astronomy Toronto last year was Dr. Ian Halliday of the National Research Council in Ottawa, and just recently, just last January, he photographed Halley's Comet with Canada's telescope in Hawaii, the Canada-French-Hawaii telescope on top of Mauna Kea. He says it's still a very faint object, only bright enough for the largest telescopes in the world to see, and it still looks like a star. It doesn't look like a comet yet at all. Well, the Toronto Centre will be scheduling several star nights later on in the year to give the people of Toronto a chance to see Halley's Comet, because you are going to need to use fairly large telescopes to get a good view of the head and the tail. And we have a slide of Halley's Comet, what it looked like in 1910. And if we get that up, you'll be able to see that the Halley's Comet was quite spectacular, a very, very long tail, and I believe that bright star there is Venus, the way it looked back in 1910. So it's been 76 years since Halley's Comet was visible in the sky. Now, one thing we should warn you about is that you do need a large telescope to see Halley's Comet very well, but do not go out and buy a $2,000 or $3,000 telescope just because you think you may miss seeing the comet. Again, a lot of members of the Toronto Centre, it's their hobby to save up, buy large telescopes so they could use it all the year round, and we'll be making these large telescopes available to the public with star shows, star parties in parks down by the lakefront, again, November, December, and early next spring. I should warn you that there may be some advertising of telescopes in the $200–300 range. They may advertise that you can see the comet very well with them. You might be able to photograph them. Well, the thing is, that may not be the case, and if you're unsure, phone the Toronto Centre of the Royal Astronomical Society of Canada at the planetarium, and there'll be someone there who will be able to help you out with that. Now, the Toronto Centre, I'd like to say a few words about it. The Toronto Centre has about 800 members, amateur and professional astronomers, and if anyone is interested in astronomy, learning a bit more about astronomy, we have meetings every other week at the planetarium where we have lectures by professional astronomers and by amateur astronomers. Amateur astronomers just like my guest later on tonight, Jillian Buriak, people who go out and look at the sky for their own hobby. Now, our annual dues are only $20. It's less than, you spend more when you fill up your car with gas these days. But one of the booklets that you get is what's called the Observer's Handbook. And I'm showing you the Observer's Handbook tonight because of recently a new law has come in Ontario that you have to have your car lights on a half an hour before sunrise and for a half an hour after sunset. Well, lo and behold, there are listings in here of when the sun rises and sets. So if anyone's interested in getting that, apart from moon rising, moon setting, where you can see the planets, and a whole bunch of other interesting information, you can join the Royal Astronomical Society of Canada and you get this apart from some other publications free. Another thing that's going on in the sky in February and March is the planet Venus. And we have a slide of the planet Venus that we can get up. It's a very, very bright star seen in the west about an hour after sunset. And if you look in the sky, then again, February and March, about an hour after sunset, you'll see a very, very bright star. It looks like an airplane arriving at the airport, but it's actually the planet Venus, and you can watch it as it sets. This is a slide showing the moon, the crescent moon, which is very close to the planet Venus. And at that point in time, Venus, of course, is one of the planets. It's the planet closest to us. It's covered in clouds, and by the end of February, it'll be very, very bright, the brightest thing in the sky apart from the sun and the moon. Well, the moon is what we'd like to talk a bit about tonight because it really is the easiest thing to see when you're just going out and beginning to learn a bit about astronomy. We have a slide which shows basically what the moon looks like in the daytime, and the thing to remember about the moon is it isn't a very big object to see in the sky. This slide shows the moon on an afternoon near the full phase, and this is with a normal camera. The moon isn't very easy to observe. But in the next slide, we have a view of the moon taken by Phil Moselle, a beautiful slide showing that you don't need huge telescopes to take a very nice picture of the moon. Okay, let's take a look at the next slide. And there is a very easy way to just observe the moon without any instruments at all, just with the naked eye, when it's close to planets. And here's a picture that was taken just recently of the moon close to Venus and Jupiter. And as the moon moves through its orbit, again, the moon takes about a month to go from one full orbit around the Earth. You can watch it from night to night as it changes and changes it with its phases. The next slide shows a very interesting phenomena that you can observe with the naked eye, and I'm sure many of you have, when the moon is in its crescent phase. This slide shows the crescent moon, that is the moon lit on the right-hand side, but you can see the entire moon lit up. This part where you can just see the outline of the moon is called Earthshine. And the reason that you can see this, it's very interesting. If you were standing on the moon, you would see a full Earth. So what you're seeing is not only the light from the sun lighting up the moon, but you're also seeing light reflected off of our Earth lighting up the entire surface. So you can see the full moon only when the moon is at a crescent phase. It's a very beautiful thing to see, and you may notice or may remember noticing that the full Earthshine has a bluish tinge. Well, that is because most of the light is being reflected off the Earth's ocean. Again, it's a very beautiful thing to see. Well, let's talk a bit about the phases. The moon goes through several phases during the month, and a bit earlier we set up a small moon, a 12-inch lunar globe, and we tried to simulate some lunar phases ourselves. So if we can get that tape up, we'll see 29¼ days, that's the time it takes the moon to go around the Earth, shrunk down in a period of about a minute. So here we see the moon at the beginning of its 29-day orbit around the sun. Just past what's called new moon, we've got a crescent moon. And the moon is moving around the orbit. It's appearing bigger. This is what we call the first quarter. And 2 weeks after new moon, we have the full moon. The moon is always moving at a constant speed, about 350,000 kilometers from Earth. Past full moon, the moon begins to shrink in size. It's what's called a waning moon, down through what's called the gibbous phase, in between half and full. We're down to what's called the third quarter moon, generally seen in the morning before sunrise. And we're completing the cycle now, getting to a very small crescent moon. And after this, there'll be the new moon. And then we go through the 29 cycle once again. So that's, in just a minute, the entire orbit of the moon. Now we have some slides, and let's get those slides up. We'll take a look at some photographs taken with an amateur-sized telescope and see some real phases of the moon. The first slide we're going to see is a crescent moon. This is taken, say, with an 8-inch telescope, and you can begin to see some of the features on the moon. The next slide shows a bit bigger crescent, again seen in the evening sky just after sunset. And the next slide we'll see a bigger moon. It's in between first quarter and full. It's called gibbous, and now a lot more of the features are seen. And in the last slide of this series we have the full moon. And you begin to see that a lot of the features aren't as clearly seen, although you begin to see the darker and lighter features on the moon. Well, the next slide shows a very interesting phenomena. It's called the moon illusion, and a lot of you might wonder or have thought about it before. Why does the full moon look so big when it's rising? Well, in this slide we'll see several things about the moon when it's rising. One is it looks squished. The sun also looks a bit squished when it rises and sets. Also, it has an orangish color, and it's very interesting, the full moon looks pretty big, or anytime the moon looks quite large when it's down close to the horizon as opposed to when it's higher in the sky. And there have been some studies with regard to this, and it's just basically an optical illusion. Well, now we've looked at the moon, what we can see with our naked eye, the phases, the moon passing near to bright stars and planets, and the moon illusion. What about binoculars? We can use binoculars to look at the moon and begin to see some of the details that we saw with the telescope shots there, things you can't see with your naked eye. We have a slide which shows the full moon, pretty well what it would look to someone using binoculars, and again you can begin to see some of the craters. You can see the darker areas, which are the seas, and the lighter areas, which are called the highlands. And there, again, astronomy with binoculars is a great way to get to step up from naked eye to telescopes. Well, what if you got a telescope? Everyone who comes to the Toronto Centre star parties and sees the moon through the telescope for the first time is amazed at the number of things you can actually see. Well, I've got a few slides of the moon taken through, again, an amateur telescope, and the first slide will show you that there is an incredible amount of detail that you can see with a telescope of just the moon at any phase. Begin to see individual craters. Near the dark, where the dark and light areas are, you see that there's a lot of fine detail. This is called the terminator. We can see rays coming out from some of the younger craters on the moon, and again we can see the lighter and darker areas. Let's go to the next slide. In this next shot we'll see again some mountain ranges. The features going up through the center of the screen is an actual mountain range on the moon. The next slide will show us a good example of what's called a sea. To the left and to the bottom there, the darker areas, those are called seas. When Galileo first used his telescope, he thought they were flat oceans. Actually, we know them to be flat plains. The lighter areas are the mountains. And certainly with telescopes, you can easily see this with your naked eye, and it's really a treat to have a nice clear sky and to be able to look at the moon. The last couple slides we have are rarer things that you can see when you look at the moon, and those are eclipses. This is an eclipse, a partial eclipse of the moon seen a couple years ago in Toronto, and the next eclipse of the moon from Toronto is, I believe, in 1988. So we've got a few years to wait for an eclipse of the moon. The next slide shows an eclipse of the sun, and this is much rarer. We're going to have to wait a long time to see this from Toronto, but certainly the moon and the sun line up every now and then so that the shadow falls onto the Earth. Well, that's just a very short introduction as to what you can see if you go outside and look at the moon. There's a book here that is very good for looking at the moon or learning about the moon. It's called Night Watch. It's by Terence Dickinson, and he is a member of the Toronto Centre, and he also writes for the Toronto Star. So that's Night Watch, and it's available at science stores in the city. Well, in a minute we'll be back with Jillian Buriak, who is a member of the Toronto Centre and a very avid amateur astronomer. Well, we're back, and I have as my guest Jillian Buriak, who is one of the younger members of the Toronto Centre of the Royal Astronomical Society of Canada. And Jillian, I'd like to welcome you onto Astronomy Toronto.
Thanks, glad to be here.
Jillian, I guess my first question would be, how did you get interested in amateur astronomy?
Well, we used to live up north, our family did, up in northern Ontario where the skies are just great, and you could see the Milky Way and all kinds of things. And I remember being fascinated as a little kid, just looking up at the sky, and it gradually developed until about grade 2. I got my first telescope, and then in grade 9 I finally joined the Royal Astronomical Society, and from there it's come to here.
Yeah, and you've brought your telescope with you. Could you tell us a bit about it, how it works?
This is an astroscan telescope, and it's a good beginner's telescope because it's really simple to use. You don't have to worry about all kinds of things like declination and altazimuth and stuff like that.
So basically you just point and look?
Yeah, that's all you do.
Little shoulder strap?
Yeah. You can put it right on your lap if you want to and just aim around. And there's just a big primary mirror in here, and it focuses the light into this eyepiece here, which then focuses it for your eyes so you can see things.
What are some of the things you like to look at with this telescope?
Well, I remember the first thing that I ever saw was the full moon, and then came to things like the Orion Nebula, which is one of the brighter ones, which you can see with your naked eye, and other things, other galaxies, and gradually as I became more experienced, I got into more difficult things, until now I can see quasars. I saw one.
Oh, really?
Recently, yeah.
Oh, that's fantastic. A lot of people think that the most beautiful thing they've ever seen through a telescope is Saturn. Do you remember the first time you ever saw Saturn through a telescope?
Yes, I do. I was just astounded because you see pictures of it and it's always really blurry, and because the planets are very difficult to photograph. And then I looked through the telescope and it was this perfect little image. There was no blurriness at all, and you could actually see one of the moons tighten there, and it was just magnificent.
You were with us on an eclipse trip in last May, and I bet you remember that very clearly.
Very clearly. That was something you just can't forget. It was just so different from anything you'd seen. It was just great.
You know, you've mentioned that you can't photograph things as well as you can see them through a telescope. Is that what led you to begin to draw some of the things you see through the telescope?
Well, actually, photography is a difficult thing to get into because it's difficult to do, and the equipment is expensive, and you have to get special telescopes and cameras and stuff like that. So I had pencil, paper, so I just went out and started to draw, and I realized that you could see things that a camera couldn't, because a lot of the things that your eye sees just won't register on film. So I started getting into kind of different things, starting with the moon, and then I got into deep sky, which is galaxies and nebulas, things like that.
Well, let's take a look at some of these things you've drawn, Jillian, and we'll take a look at the first one. I believe this is the full moon. We've been talking a lot about the moon tonight. Tell us a bit about this drawing of the full moon.
This drawing I did just before a lunar eclipse in July of 1982, and I was out in my backyard, and before the eclipse started I was waiting around, and then I decided to draw it, and I'd never really drawn the moon before, so I just was sketching and did a whole bunch of sketches, and then from those I took them inside the next day and then drew a finished product of that, and then I came out with this drawing of the full moon.
It looks quite intricate. How long would it take you to do something like that?
That took me a long time. The preliminary ones, I didn't make them as detailed because I was outside and I was freezing cold, so I just did really quick ones. And then I took those and then I put them in, and that picture probably took me about 8-9 hours to draw.
Okay, the next one is what's called a libration, and this is quite an interesting drawing. Tell us a bit about what a libration is.
Well, the moon always keeps the same face towards the Earth as it rotates around, but sometimes you can suddenly see a little bit more. The moon, you can see, because of a different angle, you can see an edge of the moon that you normally can't see, and that's called a libration. So they don't happen that often, so when this happened, I went out and was drawing it, and you can see a little bit more of one side of the limb, a place called Mare Australis, that's the Sea of Australia, and you can see it more, which you normally can't see.
That's great. And I don't think I've ever seen a photograph of this. It's very rare to see it. The last one I really like, because there isn't a photograph by any telescope as clear as this drawing you've made. This is of one lunar crater. What is this crater called?
Eratosthenes.
Do you have any idea how big it is?
No, I don't, but actually that's probably about 100 kilometers across.
About 100 kilometers. I think you're right. Tell us a bit about how long it took to draw this.
That one I drew right from the telescope. I put it on the highest power I could, and that isn't really that strong with this telescope, because this is meant to give you wide views of the Milky Way and things like that. So I could see the entire full moon through this, and so that means it wasn't that magnified. But your eye can close in on it, whereas a camera can't that easily. So I just closed in on it and drew it larger than I actually saw it. You know, I sort of blew it up in my mind and just drew it like that, and came up with that.
Now, as you're sitting at the telescope, the atmosphere is quite turbulent when you look through a scope, so you're basically waiting for a nice clear view, aren't you?
Yeah, you are. And that's the trouble with photography, is because photography takes an exposure and the atmosphere is bouncing around, and that's why the light suddenly becomes bouncy and goes on the film bouncy, and then you get the blurriness.
Yeah, that's one thing I've always noticed through a telescope, is when you're looking at, say, a planet or something that has detail, you sit and you wait for the few seconds where the air settles down. And I can see with photography, I mean, for drawing, that would take a while, because you have to wait just for those few minutes.
Actually, I didn't really find that, because I could just take composite pictures. I could just look at it, and then I see that detail, and I see that detail. And then maybe when it did clear up, then I could see it as a whole and then put it all together to unify it. But actually, you didn't have to wait like that.
Oh, that's interesting. You also have a beautiful series of color pastel and pencil drawings of the lunar eclipse in 1982, and this is a beautiful sequence. Tell us about what we're seeing here.
And it's over the silhouette of my house, which is the darker black on the bottom. Excuse me. And I did it as the Earth rotates. It appears that the moon travels across the sky. So I then did each one where it appeared, each moon where it appeared over my house during the sequence when the moon passes through the Earth's shadow, and then it's right in the central part of the shadow. That's called the total eclipse. And then when it comes out, and by the time it comes out, it's morning. So.
And it really was this reddish color, wasn't it?
It was very red. It was very, very difficult to see, and even more difficult to photograph. So actually, people who drew this had a little more of an advantage than people who photographed it.
You really did, because my photographs didn't turn out very well at all. It was a very dark eclipse. I think it was a very hazy night, too.
It was extremely hazy, yeah.
That's really good. Now, did you do a lot of sketches during the time and then go back and do the color?
Oh yeah, I did a lot. I was practically drawing constantly, or ran inside to get warm a couple times.
What do you like better, the pastel or pencil?
The pastel is better for the color ones, because in the mid-eclipse, when it was in the Earth's shadow and it became, all these colors came out, pastel was just the thing to do, because then you could catch the color. But for the other ones where you're doing little details, pencil is better.
Well, Jillian, you've really added a lot to Astronomy Toronto by doing the set. This is the third set we've had in 5 years, and it is by far the best.
Thanks.
It is spectacular. What did you use to paint this set?
I just took tempera paint, the powder tempera, mixed up with water and added some egg, so you get egg tempera, and then just painted it on here.
Okay, we're going to look at some of these objects, because they are deep sky objects. They don't look quite like this through your little telescope.
No.
But let's look at this one here. What we have is the globular cluster.
That's M31. It's a Messier object in the constellation Hercules.
Okay, so this is something that, again, you see with a larger telescope, but you can see this with a smaller telescope. And the next one?
Well, that one over there, that's behind me, that's the Horsehead Nebula.
Okay, what's this one here?
That's the Orion Nebula.
Right, and this is a beautiful object to see.
You can see that with your naked eye, actually.
Yeah, not quite as red. It usually looks greenish with the naked eye, but yeah, you can see it. And again, this is a place where stars are being born. And I think behind me here is...
The Sombrero Galaxy.
This is the Sombrero Galaxy. And again, a galaxy like the Milky Way galaxy. Again, like the Milky Way galaxy, sure. And taken through a large telescope. Well, that's super. Again, these are things that one can see through a larger telescope, I think.
Yeah, that's right.
But, so what do you look forward to in drawing? What is your next project?
My next project, I want to do something really different. I was thinking of, rather than just doing things like this where I just take a Milky Way object and then draw it, I was thinking of maybe doing things like with planets that I could imagine around these, and maybe the inhabitants of these planets, that could be very different from humans.
So something like, well, there are a lot of space artists like John Lomberg who do things like this. Basically things you can't see through your telescope, but things you would imagine.
Yeah.
That's great. Thanks very much, Jillian, for being on Astronomy Toronto. It's been a pleasure having you on.
Thanks.
Good luck with your paintings and your drawings.
Thank you.
And I'd like to thank you for watching Astronomy Toronto. Again, Astronomy Toronto is seen on the first Thursday of every month at 8 o'clock in the evening here on Rogers Cable 10. And we're Toronto's astronomical news magazine. If you want to see anything on any topic of astronomy, get in touch with Rogers, and through them, hopefully they'll give me an idea of what you'd like to see. Again, if you want any information on the Toronto Centre of the Royal Astronomical Society of Canada, you can get in touch with us, care of the McLaughlin Planetarium, 100 Queen's Park in Toronto. So again, my name is Randy Attwood. Thanking you very much for watching Astronomy Toronto, and we'll see you next time.